Another device used to prove abstract inequalities is to add inequalities, especially similar inequalities. So A, B, C, and D are elements of the real number set. Number 1, prove that a to the power of 4 plus b to the power of 4 is greater or equal to 2a squared b squared, and write down similar results for b to the power of 4 plus c to the power of 4, c to the power of 4 plus d to the power of 4, and d to the power of 4 plus a to the power of 4. So we have a to the power of 4 plus b to the power of 4 is greater or equal to 2a squared b squared. So the first thing we're going to do is bring the 2a squared b squared over the equal sign, and it becomes minus 2a squared b squared. So we have a to the power of 4 minus 2a squared b squared plus b to the power of 4 is greater or equal to 0. We're going to break down minus 2a squared b squared to be minus a squared b squared minus a squared b squared. So technically this is minus 1a squared b squared, and this is also minus 1a squared b squared. So we have a to the power of 4 minus a squared b squared minus a squared b squared plus b squared to the power of 4 is greater or equal to 0. So now what we're going to do is factorize the first two terms and then factorize the second two terms. So factorizing a to the power of 4 minus a squared b squared, a squared is going to be our HCF, or highest common factor, because remember the factors of a to the power of 4 are a squared times a squared, because when we're multiplying powers with the same base we add the powers, so it's one of our laws of indices. So a squared into a to the power of 4 leaves us with a squared, and a squared into minus a squared b squared leaves us with minus b squared. Next we're going to factorize the right two terms. So we have minus a squared b squared plus b to the power of 4. So b squared is going to be our highest common factor. B squared into minus a squared b squared leaves us with minus a squared, and b squared into b to the power of 4 leaves us with b squared, because the factors of b to the power of 4 are b squared times b squared. And this is all greater or equal to 0. Now we almost have what's inside our brackets matching, except our signs are different. So we're going to change this plus b squared to minus b squared, this minus a squared to plus a squared, and this plus b squared to minus b squared. Now we have what's inside our brackets matching. So a squared minus b squared is inside both sets of brackets, so that's going to be one factor. Then we bring down the a squared and the minus b squared, so that's our second factor, and that's greater or equal to 0. Since we have the same thing inside both sets of brackets, we've got a squared minus b squared squared, and that's greater or equal to 0. So we have proven that a to the power of 4 plus b to the power of 4 is greater or equal to 2a squared plus b squared, because this ends up to be squared, and anything squared must be a positive, and another way of saying something's positive is to say that it's greater or equal to 0. So therefore, this statement is true, so this is true. We have proven it. So now we want to write down similar results for b to the power of 4 plus c to the power of 4. So if we have a look, we had a to the power of 4 plus b to the power of 4 became 2a squared b squared. So notice that the a was the first letter, and that was to the power of 4, and now it's to the power of 2 with a 2 stuck on. So we have b to the power of 4 is now going to be 2b to the power of 2. And then we had b to the power of 4 became b squared. So now we have c to the power of 4 becomes c squared. So it's the exact same format, just the letters are different. The same goes for c to the power of 4 and d to the power of 4. So we still have a 2 stuck on front, and now we have c squared and d squared. And again, the same goes for d to the power of 4 and a to the power of 4. We have a 2 stuck on in front, and now we have d squared and a squared. So the exact same format as what we were asked to prove at the very start, just with different letters. Part 2. Deduce that a to the power of 4 plus b to the power of 4 plus c to the power of 4 plus d to the power of 4 is greater or equal to 4abcd. So remember in part 1 we got b to the power of 4 plus c to the power of 4 is greater or equal to 2b squared c squared. We got c to the power of 4 plus d to the power of 4 is greater or equal to 2c squared d squared. And we got d to the power of 4 plus a to the power of 4 is greater or equal to 2d squared a squared. So what we're going to do is list all of our equations So we were given the first one, a to the power 4 plus b to the power 4 is greater or equal to 2a squared b squared. So that's the first one. And then I've just listed the rest underneath. And we're going to add them. So a to the power 4 plus a to the power 4 is 2a to the power 4. B to the power 4 plus b to the power 4 is 2b to the power 4. C to the power 4 plus c to the power 4 is 2c to the power 4. D to the power 4 plus d to the power 4 is 2d to the power 4. And then we have our inequality symbol. Then 2a squared b squared plus 2b squared c squared plus 2c squared d squared plus 2d squared a squared. Now we notice we have a 2 attached onto every term, so we're going to divide across by 2 to simplify. So we get a to the power 4 plus b to the power 4 plus c to the power 4 plus d to the power 4 is greater or equal to a squared b squared plus b squared c squared plus c squared d squared plus d squared a squared. Then I'm going to rearrange my terms so I have anything with an a together. So I'm going to have a squared b squared plus d squared a squared. And then I'm going to put anything with a c together. So b squared c squared plus c squared d squared. I'm going to factorize these first two terms. So I've got a squared as my highest common factor. A squared into a squared b squared leaves me with b squared. A squared into d squared a squared leaves me with d squared. Then I'm going to factorize my second two terms. C squared into b squared c squared leaves me with b squared. C squared into c squared d squared leaves me with d squared. So I notice I've got b squared plus d squared inside both sets of brackets. So b squared plus d squared is going to be one of my factors. Bring down the a squared and the plus c squared. That's my other factor. So I have b squared plus d squared multiplied by a squared plus c squared. Now b squared plus d squared ends up giving us 2bd, and a squared plus c squared ends up giving us 2ac. So let's have a look at where this came from. Well, if we go back up to the top here, we have a to the power 4 plus b to the power 4 is greater or equal to 2a squared b squared. Well, if we were to divide across just the powers by 2, we would have a to the power 2 plus b to the power 2 is greater or equal to 2 times a to the power 1 times b to the power 1, which would be the same format as what we would have here. So if we had b squared instead of b to the power 4 plus d squared instead of d to the power 4 is equal to 2 times b to the power 1 instead of b to the power 2 times d to the power 1 instead of d to the power 2. So let's just see, can we prove this? So let's let b squared plus d squared be greater or equal to 2bd. So b squared plus d squared is greater or equal to 2bd. We're going to bring the 2bd over the equal sign. It becomes minus 2bd. So we have b squared plus d squared minus 2bd is greater or equal to 0. We're going to split up the minus 2bd to give us minus bd minus bd. We're going to factorize the first two terms. So factorizing b squared minus bd, we get b outside the bracket. B into b squared leaves us with b. B into minus bd leaves us with minus d. Now we factorize the second two terms. So we're going to take out minus d as the highest common factor. Minus d into minus bd leaves us with b. Minus d into d squared leaves us with minus d. And all of this is greater or equal to 0. Notice we have b minus d inside both brackets, so b minus d is one of our factors. Bring down the b, bring down the minus d, so b minus d is our other factor. So b minus d times b minus d gives us b minus d squared, which is greater or equal to 0, because anything squared is greater or equal to 0. So this statement is true. Therefore, b squared plus d squared is greater or equal to 2bd. So that's how the b squared plus d squared becomes 2bd. So this is similar for a squared plus c squared giving us 2ac. So then we just have to multiply this out. 2 by 2 is 4. BD times AC is going to be ABCD. So this became this as B minus D squared is greater or equal to 0, which is the statement over here. Multiplying this out, we get B squared minus 2BD plus D squared, which is what we had up here. And rearranging it, bringing the minus 2bd over the equal sign, we get b squared plus d squared is greater or equal to 2bd, which is what we had at the very start. And it works similar for a squared plus c squared, giving us 2ac.